Welcome to the lecture of Earth orbiting satellite, orbital parameters, and through orbital simulation tool, we are going to study how the satellites are orbiting. Okay, before entering into this topic in depth, first we should know what is the meaning of satellite. If an object that moves around a bigger object, it is said to be a satellite. Basically, there are two kinds of satellites. One is natural satellite, that is, for example, Earth is moving around Sun, hence Earth is satellite to Sun. Similarly, Moon is satellite to Earth. And second one is man-made satellite. It is also said to be artificial satellite, and it is designed for specific purposes like broadcasting, remote sensing, weather monitoring, space communication, and so on. Let's move on to the topic Earth orbiting satellite. First one is LEO orbit. These satellites are placed 500 to 1500 kilometers above the surface of Earth. Due to lower latency, these are mainly used in remote sensing and provide mobile communication services. Second one is medium Earth orbit. It can be positioned somewhere between low Earth orbit and geostationary orbits. So these orbits around 10,000 kilometers above the surface of Earth. And last one is geostationary orbit. So these are all synchronous with respect to Earth and is important orbiting satellite. It is looking from a fixed point from Earth. These satellites appear to be stationary. Right? Whenever we are looking from a fixed point from Earth, these satellites appear to be stationary. These satellites are placed in the space in such a way that only 3 satellites are sufficient to provide connection throughout the surface of the Earth. There are 3 conditions which lead to geostationary satellites. One is the satellite should be placed 36,000 kilometers above the surface of Earth. And second one is these satellites must travel in the rotational speed of Earth and in the direction of motion of Earth, that is eastward. And last one is the inclination of satellite with respect to Earth must be 0 degree. Usually the geosatellites are used for TV and radio broadcast, weather forecast, and is operating as a backbone of telephone networks. Basically, the Earth orbiting satellites are defined by orbital elements which are referred to as Keplerian elemental set. They are, first one is eccentricity, second one is semi-major axis, apogee, perigee, true anomaly, ascending node, descending node, inclination, argument of perigee, and finally right ascension. So we are going to discuss in detail about these parameters. The first one is eccentricity. So it will give the shape of the satellite's orbit. And second one is semi-major axis. So as we all know about, the ellipse will have major axis and minor axis, and in major axis the half of the value of major axis is said to be semi-major axis. And next one is apogee. Apogee is nothing but a point for a satellite furthest from the Earth. It is denoted as HA. And perigee, a point for a satellite closest from the Earth, that is called perigee. True anomaly, it is the angle from point of perigee to the satellite position measured at the Earth's center. And next one is ascending node. So ascending node is nothing but the point where the orbit crosses the equatorial plane going from north to south. And similarly the descending node, the same definition from your ascending node, and it will going from south to north. And next one is inclination, the angle between the orbital plane and the Earth's equatorial plane. It is measured at the ascending node from the equator to the orbit, going from east to north. Next one is argument of perigee. So it is nothing but it gives the rotation of orbit's perigee point relative to the orbit's line of nodes in the Earth's equatorial plane. And finally, right ascension. So they relate the orbital plane's position to the Earth. So let's move on to the topic orbital simulation tool. So it will work under these kinds of orbital parameters. So let us discuss on the orbital simulation tool. So as we discussed earlier, we have these parameters, particularly eccentricity, semi-major axis, true anomaly, inclination, argument of perigee, and then right ascension in degrees. So now we are going to simulate with these parameters as mentioned with some values. Now I am going to simulate this. So after simulating that, we will receive some 3D visualization. It is going to be placed here. So wait for a while, it is loading. So in that 3D visualization, we can observe what about the orbit position and the inclination, eccentricity and so on. For example, if I am changing the eccentricity value is 0.4, and what about the orbit size shape? So I changed the eccentricity as 0.4 with the remaining parameters as like. Okay, so now I'm going to change the inclination as for example, I'm changing it into 90 degree. Then what about the result? So it shows this. Under that, the satellites revolving in that position. So you can easily observe where the satellite is positioned, how and where the path is identified and so on. Thank you.